cut out, I don't know, say a donut, and that would be say 500 calories, and that's quite a big impact on energy balance. Whereas for somebody to burn 500 calories, that's probably going to be, you know, the best part of an hour of exercise. But ultimately, just being active is really important. And of course, we've got the physical activity guidelines, 150 minutes of moderate or 75 minutes of vigorous, don't sit down too much. So there are some guidelines for general health, as well as condition-specific guidelines. But I think the general message is that all activity is useful. Your body and your brain is set up to defend against negative energy balance and weight loss. So if you develop obesity, it's incredibly hard, because as soon as you try and go on a diet, for example, your hormones change, your areas of your brain, like reward-related pathways in your brain change, so you crave sweet food, foods high in fat, your metabolic rate will drop. All of these efforts to try and get you to eat more and expend less so that you don't lose the weight.
Hello and welcome to the Experts in Health podcast, brought to you by Loughborough University. This podcast aims to highlight the latest research and trends in health as we welcome a variety of guests from a host of different disciplines. I'm Dr. Chris McLeod, an academic in the School of Sport, Exercise and Health Sciences with an expertise in behavioural nutrition and public health. And today I'm delighted to be joined by Dr. James King. James is a senior lecturer in exercise physiology at Loughborough University. James, welcome to the podcast. Thanks very much for coming on.
No problem at all. Well, thanks Chris, thanks for the invitation to come on to the pod.
Not at all. I'm really looking forward to seeing what we chat about today. But to begin with, am I right in thinking that you are a real product of Loughborough University? You've been here a little while.
I have, yes. The question is, how far do you go back? So I grew up quite close to Loughborough, and even as probably a 11-year-old, we used to get bussed over here to take part in experiments within what is now our school, and to run around the track in the regional athletics. But then I went on to be an undergraduate and have never left.
Well, if it works for you, then stay on. So just tell us a bit more meat on those bones. Tell us a little bit about yourself, what you do in your career, what your expertise is, all of that.
Yeah, so I guess by trade I'm an exercise physiologist, and when I was sort of going through my undergraduate degree, I developed an interest more in the health arena, initially around appetite regulation, energy balance, but within the broader area of obesity. And I suppose over the last sort of 10 to 15 years now, that's extended even further from looking at the basics around obesity to the applications with regards to obesity-related health conditions like type 2 diabetes and severe liver disease and that sort of thing. So I have this broad research sort of interest around obesity-related conditions, but particularly using exercise and to a certain extent nutrition as well to try and tackle these conditions, to either prevent them or to help manage them.
Really interesting. So just to help our listeners, to whet the appetite, can you just give us a brief opening sort of statement to say why what we're going to talk about today is so important to you and should be to everyone tuning in?
So yeah, with that focus, that central focus on obesity, that's been something that's really fascinated me for years, just the mechanics around obesity, but also then if you think about how common obesity is, but also how stubborn it is proving to be. Governments have tried to tackle this all over the world with very little success. So that is a global health issue I find really interesting, particularly in the current environment where we have new obesity pharmacotherapies, new medicines coming about that seem to have some quite effective uses. We'll leave that there for now. But using lifestyle, because ultimately one of the reasons why we have obesity is because of people's lifestyles. We live in an environment where physical activity has been engineered out of it, and in a kind of like an obesogenic food environment where energy dense, nice foods are all around us. They're cheap, they're easy to access. So part of the issue is our lifestyle. Therefore, part of the solution theoretically could be or should be lifestyle therapies like exercise.
And obesity and the prevalence of it has been getting worse, hasn't it? Since when roughly has it been getting worse from?
People typically start to say, around sort of the 50s, 60s, you start to see a bit of an uptick, particularly in sort of Western countries. So, now we look at it, in sort of high income countries like the UK, levels are going up, but quite quite steadily now, not dramatically, whereas in low-income nations across the world you see a steeper increase. The issue we have now is that, and this sort of gets hidden by the figures because people talk about general obesity, although general obesity levels might be staying relatively still or increasing marginally, it's the levels of severe obesity. So people with obesity don't just have a BMI of say 30, those with severe obesity over 35, where the real health problems kick in. We're seeing more people sort of enter those areas within the BMI sort of context.
Interesting. And then when you couple that, I guess, with just a growing population of the UK and the world, that you just get more problems for resources, whether that's the services or support services, but also for more individuals as well who have these knock-on effects of obesity as well.
And linked to that, obviously obesity develops more with ageing. So with an ageing population, people living longer, that's almost a double whammy as well. So with implications for how the with the knock-on implications for the health service, funding that, but also people's quality of life and longevity as well.
Okay, so just thinking about the things that I've sort of written down for us to talk about today, and I've sort of given you a piece of paper just so that you got that noted. We've got the environmental factors that can influence obesity and whether people will develop obesity over time, but have the hormones that we have, the way that our body's structured and the way that we sort of go towards food, our appetite, how does that work? Has that changed as well over time?
Which way do I go with this? So one thing we are learning a lot about, and it's not an area that I am active in, so I'm not a fountain of all knowledge, but the genetics around obesity has been something certainly within the last 10 years, in my sort of time working in this area, the knowledge generally is expanded enormously now. So when I was sort of studying sort of PhD level, we were talking about very rare cases of what we call monogenic obesity. So these are individuals who develop obesity at a very young age because they have a genetic defect in a single gene related to appetite. So these genes typically within the brain, that means that their brains think they're starving all of the time. So we had that goes back sort of 15, 20 years. But what we're now realising now is that the genetics of more common obesity, and even the genes around thinness as well. But we now know that there are over 1,000 areas of our genetic code with variants that link to obesity-related traits like your BMI or body fat levels. And we can measure these now with developments in technology. You can look at somebody's entire genome and see how many of these variants or risk alleles that somebody has. And there's some really nice studies where they followed people for 20 years or more, and they can genotype people and look at your genetic makeup, and it's quite clear that people with more of these at-risk variants over time gain more weight than people with fewer variants. So the genetic contribution to obesity is an area that we've learned lots about. But there is also within those studies quite a nice message that actually, even if you take people or look at people with high genetic risk, if they do lots of physical activity and or have a healthy diet, statistically within observational studies those individuals don't gain the weight. So there's a message there that some people have higher risk, but actually there's, in terms of weight gain, the potential to reduce that risk if you're able. And I say able because not everybody's able, but if you are, you can. Your genetics aren't destiny, if you like.
Yeah, so it's not purely deterministic. It's not saying, just because you're born and these are the genes you've been given,
yes,
you can't do anything about developing it.
So that's for what we call the polygenic or common obesity. If you've got those monogenic forms I spoke about, you're going to have obesity because your brain thinks you're starving. Whereas more common obesity, yes, if you have higher risk, you're more likely to gain weight or more weight over time. But and it's important if you're able, because if you are on a low income and buying healthy foods is very difficult, then your ability to actually engage in physical activity or eat a healthy diet is less than other people. So, yeah.
And for people who have the monogenic obesity that you mentioned, is the way that they feel hunger and the way that their hormones drive them towards or away from food, is that actually different for people who have the polygenic obesity or the more common obesity? Have you any ideas on that?
So we haven't looked into sort of the endocrinology and the hormonal aspect, but basically so for example, some of them they're not common because these are rare syndromes, but people talk about leptin deficiency. So leptin is a hormone released from your body fat that basically tells the brain about how much stored energy you have. So if you have more body fat, you have higher levels of leptin. But if you have a genetic defect whereby your body doesn't make leptin, your brain is not sensing that signal that tells it how much energy it has stored away. So it's thinking that you have no energy, this is not good from a survival perspective, you need to eat. So then, you interpret that as hunger and needing to eat all of the time. And a lot of those, or a few of those sort of monogenic forms of obesity are related to leptin deficiency, leptin receptor deficiency, or some of the pathways in the brain that relate to appetite within an area of the brain called the hypothalamus.
Interesting. Okay, so talking very sort of basically, we talked about the energy that goes into our body there. What we eat is, what comes in and it's transferred into it's energy within our body. And then you've got the expenditure side of things. When we do activity, how do those two, just not necessarily thinking about obesity at the moment, but how do those two things interact? The amount that you eat, the type of foods that you eat, and the exercise that you do. Is there any way that you can sort of just introduce that interaction?
Yeah, so obviously it's the textbook sort of energy balance set of scales that you show to your undergraduate students. On the left-hand side, you've got energy intake, which is your carbohydrates, fats, proteins, alcohol if you drink alcohol. So that's on one side, and then the other side of the equation, you have your resting metabolic rate, which is usually around about 2/3 of energy expenditure. You've got your what we call the thermic effect of feeding, which is basically the energy you have to expend to process and digest and deal with the nutrients that you eat. And then you've got the more variable component, which is your physical activity. And that can obviously range from somebody who's bed rest in hospital with 0, or it can range to somebody cycling up the Alps in the Tour de France, or an Arctic trekker expending 8,000 to 12,000 calories a day. So there's enormous variation in that energy expenditure, so the physical activity energy expenditure side of the equation. But you're right in terms of the interaction. People often really think of those sides in isolation. But for example, what you eat affects your energy expenditure. So if you're, for example, one of the reasons why dieting is difficult is because if you start to eat less and influence this side of the equation, then your body says, what are you doing? This is silly from a survival perspective. So energy expensive process and your resting metabolic rate become lowered because your body's trying to help you maintain that energy balance rather than creating an energy deficit. And even on top of that, there's guys at Duke University in America, a guy called Herman Ponzer, who's got a theory that's quite polarising, I think, to a certain extent, but basically saying that with more physical activity energy expenditure, as you do more physical activity, actually your resting metabolic rate shuts down. So the idea that we all sort of think if you do more physical activity, total daily energy expenditure goes up in a linear fashion. But what some of the anthropological evidence, so they compare energy expenditure in like Westerners versus hunter-gatherers in Tanzania, lots of animal studies as well, but they show that as you do more physical activity, actually the total daily energy expenditure plateaus out, and that's because burning energy on things like reproduction, immune function, these very energetically expensive processes declines. So total energy expenditure plateaus out. So doing more, the idea would be, and the implication is that doing more and more physical activity won't just automatically increase total energy expenditure indefinitely. And this is very much wrapped up in evolutionary biology.
Interesting. I mean, someone listening to that who is maybe wanting to lose weight, maybe for health-related reasons, I could see they might get a bit sort of discouraged to actually engage in physical activity then if you're like, well, I want to lose weight, and they say you should do more exercise in order to change that balance of the equation. But if you're saying that ultimately it's not going to affect anything, then why should I do it in the first place?
Yeah, totally. So the guy who sort of led that work is a chap called Herman Ponzer at Duke, previously at Harvard. So obviously a very clever guy. But so he would say, and he does say in his books, essentially that exercise is useless for weight loss. Now, what the science says from meta-analyses and the best studies we have that exercise is modest. In terms of exercise on its own, exercise has a modest impact on weight. So, if you were to start an exercise program with the view of losing weight, so somebody with obesity, you might at best achieve 2 to 3 kilos probably. And that's basically because the actual energy expenditure elicited from a single bout of exercise for most people, i.e. non-athletes, is typically quite modest. So that's one factor. So, in terms of like dieting, you can cut out, I don't know, say a donut, and that would be say 500 calories, and that's quite a big impact on energy balance. Whereas for somebody to burn 500 calories, that's probably going to be, the best part of an hour of exercise. Can you find the time to do that every day? Can you find the motivation to do that every day? You get injured. People with obesity might not have been that active historically, possibly. So it's very difficult to actually have a significant impact on energy expenditure and energy balance in a meaningful way just through physical activity on its own. That's even before you start thinking about compensation, which is something we have looked at. So once you've done the exercise, yes, you might have, if you have burnt 500 calories, do you then reward yourself for that consciously or unconsciously? Because if you then, say you're at the gym and you see the vending machines on the way out, or even the coffee machine, and you have a hot chocolate with 300 calories in it, you've just replaced a large part of what you've expended.
Yeah, and there's a piece of work that I was involved in, led by Asya Barachi, that actually showed that people can compensate before they do exercise as well. So it's sort of the planning stage also to think, I'm going to be running for 45 minutes, so I'm going to eat some before. So you can have before and after compensation as well.
Yeah.
So I'm going to take the view then from this point and say, doesn't seem to me much use for me doing any exercise then. I'm just going to watch what I eat, and exercise has got no benefit to me at all. And I'm happy about that actually, because it's hard work to do exercise, and I'd prefer to cut out a donut. Tell me where I'm wrong there. Is there benefits actually?
Yeah, particularly if you use the analogy of comparing exercise to a drug. A drug is focused on doing one very specific thing. It has a very specific molecular target, whether it's for hypertension or blood glucose, whatever it is. The beauty of exercise is that it affects a whole manner of systems and tissues without the body, so it has all sorts of different effects, whether it's on your blood pressure, your blood sugar, chronic inflammation, whatever it might be. That's not even talking about the mental health benefits. So particularly for people with obesity, who we know, obesity is linked to insulin resistance and all sorts of metabolic risk factors. Even if you don't lose weight with exercise, you will receive all of these other benefits. So I'm not saying you won't lose any weight, you will lose some, and obviously with everything, with all therapies, you get a range of responses, whether it's based on genes, psychology, but some people, although the average is a response of 2 to 3 kilos based on meta-analyses, some people will do better than that, and some people will do worse than that. So you have to, when you're thinking about individuals as well, you have to consider that. But sort of as a broad answer, no, exercise is useful, because even if you don't even lose any weight, you will receive these sort of wider benefits that will improve your health.
And is that the same all the way through the life course? For youngsters to middle age to older adulthood, exercise is always a good thing for most people?
For most people, yeah. Ultimately, I think with that, the benefits and what you're interested in will differ. So, for example, you think about, young children. And colleagues do a lot of work on bone, and you need to do your exercise to get to peak bone strength. So it's probably a slightly different focus there, particularly young children who, although colleagues might say that cardiovascular disease develops early, generally children don't have atherosclerosis, to a clinical degree. Whereas if you're then talking about people in their 50s, 60s, even younger than that now, looking at diabetes in your 40s, when these conditions are becoming more established and have developed over time with aging, your focus will differ then to more cardiometabolic risk factors. So yeah, just a different emphasis, I think.
And with that emphasis, what types of exercise have these metabolic benefits that you've sort of talked about, in terms of disease. I know, we hear about resistance training. You've got everything from doing some Pilates or some TheraBand work at home to lifting heavy weights at the gym, and then you can go into the even more granularity and say you can lift 2 repetitions for a set or 15 to 20. You've got cardiovascular work, you've got sports, there's lots of choice for people. Yeah. So where do these benefits sort of come from?
I mean, you will gain benefits from movement per se, and obviously, within our discipline, people spend a lot of time and worry a lot about defining how many reps, how many sets, duration, and all of this. But generally, the message to people would be to just be active, and indeed, there's a whole with lots of colleagues have a strong interest in even sedentary behaviour, just sitting down too much, and there's lots of evidence now that actually just reducing sedentary time can be beneficial. So of course, we can work towards almost like a more detailed and even personalised prescription in terms of, for your particular condition or your particular interest, it's better to do this and then do that. But ultimately, just being active is really important. And of course, we've got the physical activity guidelines, 150 minutes of moderate or 75 minutes of vigorous, don't sit down too much. So there are some guidelines for general health, as well as condition-specific guidelines. But I think the general message is that all activity is useful. But where we are going towards is a point where, particularly when within my area of clinical exercise science, if you've got a patient with hypertension or type 2 diabetes, we do have enough evidence to say, well, actually, you probably need to do a bit more of this than that. So as an example, we do a bit of work around frailty in diabetes. So people with type 2 diabetes have almost an accelerated aging. So for example, now a lot of the medical therapies for type 2 diabetes cause weight loss, which is great because diabetes is linked to obesity. But if you're somebody in your 60s and 70s and are already developing sarcopenia and muscle wasting, and you have poor physical function, then actually the weight loss is not particularly good. So resistance training would be particularly good for those individuals, more so than aerobic exercise, which is more catabolic.
Interesting. So now I just want to add some of your thoughts rather than based in your research, but are we going towards a personalised direction for exercise prescription now? And is there still going to be room for population-wide, like the recommended daily or weekly physical activity that's out there? Are people more likely to actually go and engage if they were to be personally prescribed? Or, is there still going to be that space for it?
Yeah, I mean, it's straying out of my area now, but I think there's always going to be a place for, because it's public health, so general guidelines to try and support the population at large, which from a government and wider health perspective is what you need. There's always going to be room for public health guidelines around exercise and the general population. I guess where our discipline has gone in the last sort of 10 years or more is that we've got more granular with different conditions, whether it's physical health or mental health, and we now have good quality, solid evidence to say that actually you need a bit more of this or a bit more of that. So again, another example, even in obesity, we know the guidelines from the American College of Sports Medicine are to prevent weight gain, you actually need quite a bit more exercise than what you would need for just general health, and the same for weight loss and weight loss maintenance. So, and that's come from years of people doing research studies.
We've gone back onto obesity. So whilst we're here, on Experts in Health, we like to ask, as we can, tough questions to sort of really just get into some of the issues. And a lot of people out there think that obesity is a lack of willpower. And especially, as you've said earlier, if the genes loads the gun, but then your lifestyle and environment can pull the trigger, or you can control the way it's presented. And we see it from senior people. We even see it in the House of Commons with people saying it's about willpower and just don't drink that, whatever it is. So if we just look to address this directly, is obesity partly or fully a lack of willpower to eat less food and do more exercise?
Yeah, it's a very topical question, but and it's like you say, if you were to go out into the town centre and ask sort of the general public, they would have that view more of an individual sort of willpower perspective. If you go and speak to medical doctors, particularly those working in sort of the obesity diabetes space, who actually know more about the biology of obesity, they will say it's not at all to do with sort of a lack of willpower. And like you say, that is because, for one, we've learned a lot more about the genetics and even the epigenetics, which is how lifestyle can influence not the genetic code but the expression of the genetic code. So to give you an example, we know that the environment when you were within your mother's womb, whether she has obesity or not, even undernutrition, that can influence not just the child, but the grandchildren. Is it that person's fault that they develop obesity because of what their grandma did? So we know lots about the biology, the genetics, the epigenetics, but also the realisation now is that once people actually develop obesity, it's incredibly difficult to shake. And that's because we know a lot about the biology. Like I said before, your body and your brain is set up to defend against negative energy balance and weight loss. So if you develop obesity, it's incredibly hard, because as soon as you try and go on a diet, for example, your hormones change, your areas of your brain, like reward-related pathways in your brain, change. So you crave sweet food, foods high in fat. Your metabolic rate will drop. All of these efforts to try and get you to eat more and expend less, so that you don't lose the weight. So that's nothing to do with somebody's free will or lack of self-control. That's biology. But people don't know that. Unless you've studied that, you wouldn't know that. So I think there's a need to sort of join the gaps between the obesity researchers and that field and sort of the more general public, to try and get a greater understanding, which is important because there's a lot of stigma for people with obesity, because people think it's just their fault.
Yeah, and it's really interesting to hear that, because we've talked about how if you have obesity, it can be a large part to do with your genetics, or there's then so many factors in your environment and your sort of immediate human interactions throughout your life that can influence why you have the body composition you have. So that can sort of alleviate a little bit of feeling like, oh, it's my fault that I am in this situation, and hopefully if people learn that more widely, then that can be have less stigma associated with people living with obesity. But then to try to help people do some lifestyle behaviours that are going to be beneficial and might help them to lose some weight, because that might be beneficial for their health, you have to then sort of tap into their will to make a change, which goes into motivation, but then you're almost jumping the other side and saying, yeah, this might be the cause, but you can do something about it. There's a little bit of a tension there, I think.
Yeah, because and that's the dangers that one side would say, that if you're telling people this is nothing to do with them, they've got no control over it, then the danger is that people just give up. But we do know that even if you have obesity for whatever reason, unless it's a very rare monogenic form of obesity like we talked about, that actually engaging in exercise can have an effect. Paying attention to your diet, if you're able to, can have an effect. So we shouldn't have this sort of sense of helplessness, but we need to be more sort of aware and sympathetic. In terms of actually how you go about that, that's the psychologists who need to deal with the motivation. That's not my thing, but we shouldn't sort of take this idea that there's a biological reason for obesity and say that no one can do anything about it. That's quite dangerous. And I think that working within the obesity field, and there is a danger of that, But I think that we need to be quite careful about how the public health message around this.
Makes sense. Well, food for thought, as they say, around this. But tell us a little bit about the research that you've been doing more recently. What sort of stuff are you getting up to in your everyday?
Yeah, so my research went from PhD days to early postdoc days, looking at appetite regulation, energy balance, appetite hormones, that sort of thing. And then it progressed to looking at ectopic fat. So when we develop obesity, we start to put fat in areas where it shouldn't be stored, and the liver is one of the most important places where that builds up. The extreme analogy is foie gras. If people know what foie gras is, which is essentially force-fed geese and ducks. I think it's banned in the UK, but some European countries it's still a delicacy, sort of as a paste and a spread. But essentially, that is the liver developing or expanding 10 times the size of what it should do and building up with fat. And we get, although obviously not an artificial example like that, but in human beings with obesity, we store fat in the liver, and that has all sorts of problems because it disrupts your regulation of glucose, blood fats, blood lipids, predisposes to cardiovascular risk, and eventually long-term liver disease can happen. So the leading cause of liver transplant will soon be obesity rather than viral forms of liver disease. So we've had this general interest for probably, about 10 years now actually, in looking at the interaction between exercise, nutrition, and particularly liver fat, whether you can reduce it with exercise, and more recently looking at actually more advanced liver disease, so looking at the inflammation that happens within the liver and the scarring.
Interesting. What have you found so far?
So with regards to liver fat, so liver fat's quite dynamic. It can change quite drastically with weight loss. Exercise on its own can have an impact in terms of lowering liver fat, but particularly, we did a meta-analysis at one point looking at exercise training interventions in liver fat, and most of the benefit is due to the weight loss, even though it's obviously still 2 to 3 kilos. That can still be quite effective in terms of reducing it, but there does seem to be an independent effect of exercise. Even when you look at studies that don't elicit weight loss, you still get a slight lowering of liver fat that's clinically meaningful, and that's because exercise has metabolic benefits that might influence how the liver burns fat and these sorts of things.
Is there any benefit for exercise to prevent liver fat gain as well? So it's not just a treatment, but you can actually, doing exercise will help?
Yeah, definitely. So because of the wider metabolic benefits that exercise has. So there's a really nice study that I was talking to the students about the other day, whereby on an acute basis, they had people exercise on one occasion and then on another occasion not exercise, and then they measured using complex traces and things. They measured essentially where a meal goes after you consume a meal, particularly a meal high in sugar. I think it was fructose. What happens to it from a metabolic perspective? And if you've done exercise previously and depleted muscle glycogen, more of the meal goes to the muscle to then fill up that glycogen that you've used, rather than when you haven't exercised, the fuel goes to the liver and is more likely to be stored as fat. So even on an acute exercise basis, you can influence what happens to the nutrients that you consume, as well as priming metabolic pathways within the liver, within the muscle, all around the body, how adipose tissue functions. There's lots and lots of mechanisms.
So where's this going to go? You found out that there's those benefits for doing some exercise if you've got fatty liver to actually help reduce that fat. There's potential benefits as well for prevention, the way that the sugar is stored in your body, etc. What are you and your lab going to be looking at next?
So we've advanced this in one direction, taking it to more serious liver disease, particularly in type 2 diabetes, because if you have type 2 diabetes and high liver fat, that progresses or the trajectory to more end-stage liver disease and worse cardiovascular risk happens a lot quicker if you get the combination of the two. So we've started, and you measure this with MRI, looking at fibroinflammation within the liver. So we have trials ongoing now looking at whether exercise can reduce liver fibroinflammation, so not just fat, but the scarring when the liver's starting to become damaged. That's one avenue of work we're looking at. Another one, a more broad area, is looking at the combination of medicines and lifestyle interventions, whether that's exercise or diet, and that's within the context of obesity, type 2 diabetes and liver disease. So this is the idea that, although we like to study, it's simple if we study patients with lower risk, they're not on different medications. In the real world, if you're getting patients in their 50s with different conditions, they can be on a whole host of different medicines. So we're now looking at particularly some of the new obesity pharmacotherapies, which are really popular in the media at the moment. I'm sure people have heard of semaglutide in particular. We're looking at whether benefits can be improved or potentiated if you are physically active or if you have a particular diet and that sort of thing. So quite complex randomised trials to try and unpick some of this.
Yeah, those the drugs that are quite prevalent in the media at the moment. You say semaglutide, and Ozempic is maybe one of its commercial names, and there's others out there. What do you think about them? Does the research saying that they're going to be beneficial and they're going to overtake any lifestyle interventions that we do actually? Just take the drugs, that'll sort it out?
I think from a pure sort of medical perspective, I mean, the evidence that leads to these medicines getting approved is, robust clinical trials. So it's undeniable that like a drug like semaglutide can cause up to 15% weight loss. We've never, we can't get close to that with lifestyle interventions, particularly, well, take that back. So with low calorie diets, we can help people to sort of lose initially sort of 12-13% weight loss. But the issue we often have is with weight regain. I think one of the main benefits of these medications is that, there are studies for, up to 4 years that whilst you're taking the drugs, you get the weight loss and the weight stays off. So we've never had, when I did my PhD, we had, there were medications that were approved then, but then ultimately got withdrawn because post-marketing studies showed that they were causing all sorts of health problems. So we've had a period of time with very few medical therapies to help combat obesity. So my colleagues tell me, that particularly at the minute, the whole medical sphere around obesity is changing dramatically and it won't be the same again now with these therapies. Because as you alluded to, there's semaglutide, but actually there's another drug called tirzepatide that's been approved for diabetes, and it's been approved by the MHRA, which are the medicine sort of regulatory approvals people in the UK, and I'm sure will be approved by NICE, which make recommendations for the NHS probably next year. But there are others with slightly different mechanisms of action, some that induce more weight loss. So there's one drug called retatrutide that causes up to 25% weight loss in phase 2 trials. So these are big numbers. You're basically, what they're doing is they're approaching bariatric surgery level weight loss. So there's definitely going to be a role for these, but particularly if you think about the UK with the NHS and we don't have unlimited funds to support that. At the minute there'll be rules in terms of who is eligible for these medications.
Who gets them.
And who gets them. But then on top of that, you also have to consider not everybody can tolerate them. So some people, again, with any intervention, you get a variety of responses. And although the side effects are actually quite minimal, they you get a bit of gut discomfort, but they tend to go after a few weeks. But ultimately, that some people won't tolerate them. Some people do experience weight gain. Some people don't want to take drugs because you would have to take the drugs continuously, or the weight comes back on again. And that's exercise. And I gave a talk in Belfast a few months about this, using exercise or can exercise potentiate the benefits of these drugs. And there's lots of evidence saying that yes, they can.
Because they work towards changing similar hormones in the body, is that?
So I mean, ultimately, so take semaglutide. Semaglutide is a hormone, is a drug based on a hormone that basically suppresses your appetite. So yes, it will make you eat less and you'll lose weight and keep the weight off, but that's not going to benefit your heart. So if you're somebody with obesity, with cardiovascular risk factors, if you want to improve your cardiac function, your insulin sensitivity and things like this, exercise can have wider benefits that sort of potentiate what the pure weight loss will do. So, and there's quite a bit of evidence emerging now showing that even if you put people on these medications, if you put them in an exercise training intervention, some of the benefits are just greater with exercise. And then there's things that the drug doesn't even target. So
you're planning on doing?
So this is an area that's ripe for investigation.
Yeah.
People are starting to publish quite widely in the area now, but there's all sorts of conditions and there's lots still to unpick.
So where can people go to find more about you, what you do, what you're doing next? Where can they find you?
Oh, good question. So we all have our institutional website. So obviously if you go onto the Loughborough University website, you can search for my name and that will take you to my page, and then there'll be links to the research centres that we work within, and particularly I work quite a lot within the Leicester Biomedical Research Centre, which is essentially NHS funded research. So I do a lot of work with colleagues over at the Leicester General Hospital who are diabetes specialists as well as hepatologists in Nottingham. So if you go to the website, you'll find all of these links there.
Sounds good. And just one of the standard questions we give our guests is if you were to sell your area of academic expertise, or what you've done, your interest, to the next generation of curious minds, what would you say?
Ooh, that's a good question. I think for me, just in terms of selling it, like it's the interest and how quickly things move and how every day is different, and how research, like particularly now, like things are changing so quickly. It's quite, if you're interested in this sort of thing, it's exciting because new developments, improvements in health, applications of our trade to help combat some of these problems. For me, I find it really, really exciting, really interesting. There's days I just feel like I'm still sat at school doing my A-levels, learning about basic biology. I just love doing science. So if you're interested in science, biology, medical conditions, then for me that's enough. That's really interesting. But every day is different. You're always learning. You get to work with great colleagues, some really clever people that are quite inspiring. And we get to travel the world telling people about it at conferences and things like that, which is always nice.
Yeah, makes it sound very good. And I was thinking you might feel like you're still, back in your A-level classes because you're basically still here. Yeah. You're still in the same lectures.
Yeah.
But James, thanks so much for coming on the podcast today. It's been a joy to have you.
Thank you very much. It's been really nice to chat.
Not at all, and thank you very much for tuning in. If you've enjoyed today's episode, then feel free to like or subscribe to the podcast, and you can do that on a platform of your choice. And you can also check out our other podcast, Experts in Sport, and you can find a link to that in the show notes. So that just leaves me to say thank you once again for tuning in, and I look forward to welcoming you back to another health-related podcast in a future episode. Bye-bye for now.